Welcome to Excel and Business Math video number 23. Hey, in this video, we got to talk about important formulas for increase and decrease problems. And we will see 8 awesome examples, including a couple examples from yesterday's stock market sell-off. Here are our list of topics. We'll see decrease problems and see how to solve them using either a table method or a diagram method, and an increase problem, either table or diagram method. And we will see this list of more than 10 different formulas that will help us solve any problem. This means that no matter which 2 bits of data we are given, we can solve for every one of the other parts of an increase-decrease problem. That means that this one video, video number 23 in this entire business math class, is perhaps the most important video, the most important set of formulas, because not only in the business world, but in all areas of study, numbers are expressed in terms of percentages of increase and decrease, usually over time. All right, now we're going to start off by going over to the sheet ID. And ID means increase or decrease problems. Now, it's simple to detect whether you have an increase-decrease problem, because these will be problems where you have a begin amount that changes over time, either up or down, increase or decrease, and results in an end amount. We can think of hundreds of examples where we have a begin and end amount, house prices from the beginning of the year to the end, stock value, earnings for a company, savings account balances. Now, our basic change formula is begin amount plus the change, either up or down. And for us, if it's up, the change amount will be positive. If it's down, the change amount will be negative. When we add begin plus change, we end up with the end amount. A simple example, well, savings account at 100, you add 10 bucks. Well, the ending savings account balance, 110. Savings account balance begin of 100 plus minus 10, that's a decrease. Well, that equals the end amount of 90. Here's the begin, there's the change. We can simply say equals, there's the begin plus our change. When I hit enter, I get 110. Down here, notice, for all of our examples in this class, when we have a decrease, we're going to list it as a negative. That means equals the begin amount plus the change, plus a negative. Well, of course, that's just like subtracting and enter. Now, that's the basic change formula for increase or decrease, same formula. But there's a bunch of other formulas that we can use when we are not given the begin amount and the change amount. Let's go over and we're going to talk about an increase problem first. So I'm going to click on the sheet increase. Here's our example. We have a savings account, and at the start of the month, 100 bucks. Time went by, and at the end of the month, we had $110. Now, we want to compare the old terms to the new terms we're going to use. That means our percent formula, base, part, rate. Now we're going to say, instead of base, we're going to use begin. Instead of part, we're going to say, please show me the end part. So for these 2 terms, when we encounter them, now we're going to write begin, enter, and end part, enter. Now, the reason we're going to say end part is because there's actually 2 different parts. Notice begin is always begin, but we ended up at a new amount, so that is our end amount. But the difference between the 2, meaning 110 minus 100 is 10 bucks. That's the amount of the change, or the change part. So I'm going to write change part. By adding a new word before each one of these parts, when we get to our formula, we will make sure not to confuse which part we need in our formula. Now, for begin for us, that's 100 bucks. I already entered that here. And the end part, that's 110. Now, rate, we called it rate before. Guess what? We're going to call it rate now. We will distinguish this rate from the rate of change by referring to it as rate of change or ROC. Now, rate, that's what we'll call it here. Now, up here, we don't have formulas because we were given these. But rate, remember from our last few videos when we used these terms, well, rate, and let me bring in a picture. Now, remember we had part, base, rate, and we had the hand. So if we were solving for our rate, we would divide part by base. You absolutely can still use this circle to figure out that it's part divided by rate. But let's take this one step further. We're going to agree to use the word begin right there instead of base. So I could go like this, and now I know the formula for rate, part divided by begin. But remember, we have two different parts. So if we wanted to be explicit, we could list it as the rate end part divided by begin. All right, so with this diagram in mind, I'm going to define the formula for rate. It is end part divided by begin, tab. Now we can do our formula to figure out the rate. Equals end part divided by the begin, tab. That will give us 1.1. That's the decimal. We can format that as a percent, equals left arrow, control enter. And I'm going to go up to the home ribbon tab, drop down for number formatting, and choose percentage with 2 decimals. Now, what does that mean? We talked a lot about what a rate means in the last few videos. Because we have $110 of savings at the end of the month in the numerator, the top of the division, and 100 bucks at the beginning in the denominator, that means when we do our division, these two numbers represent $1.10 of savings at the end of the period for every $1 at the beginning of the period. And that's how we use a rate. A rate is always what you must multiply by the begin to get the end part. So that means when we multiply $1.10 times every $1 of the begin, we get the proper end amount. And we'll do that calculation in just a moment. All right, so that's the rate. What about the change part? How do we solve for that? Well, all of us could solve for that given how much is at the end and the beginning. And I chose the simple example because we can do this in our head. It increased by $10. But the formal formula is always going to be end minus begin. No matter if we have an increase or decrease formula, that formula will work. Tab, equal sign, up arrow to get the end amount minus the begin amount, and enter. So 10 bucks. And it's a positive 10 bucks. Now we need to talk about the rate of change. Remember, we're going to have 2 rates. Now, whereas the rate, notice, it's the part, meaning the end part compared to begin. But how do we use it? Rate is what we multiply by begin to get end. Well, guess what? When we calculate rate of change, it's actually going to be similar to that, but it's going to be the change part for us, 10 bucks. And it's going to be compared just as the end part to the begin. Not only that, but when we calculate this, we will use the rate of change. It will be what you multiply by begin to get the change part. Now, let's go ahead and calculate the rate of change. But guess what? We can't use this circle diagram anymore. Now we're going to have to use a different part and a different rate. So if we're trying to calculate rate of change, we use the hand covered up, change part divided by begin. So you ready? Equal sign. There's the 10 bucks, positive 10 bucks. That's our change divided by, And we're comparing that part to the begin. So when I hit tab, 0.1, that means 10 pennies for every one original dollar. That will be the amount of the increase. Now we can format that equal left arrow control enter as a percentage. When I click the drop down for 2 decimal percentage, that means 10 parts for every 100 available. Now notice we have the rate, end part divided by begin. And here we have the rate of change, change part divided by begin. Both of them are apart. Both of them are being compared to the begin. And how do we use them? Rate's what you multiply by begin to get the end part. Rate of change is what you multiply by the begin to get the change part. So let's test that. Down here, I'm going to calculate the end part. That equals the rate times the begin. Tab, tab. Equals, and I'm going to use the rate, there it is, times the begin. And when I hit enter, boom, I get exactly the end amount. Now let's calculate the change part, and that's equal to not the rate, but the rate of change times the same begin. Equals, there it is, 0.1 or 10% or 10 pennies for every dollar times the original amount. This will give us the amount of the change or the change part. Exactly a $10 increase from beginning of the month to end of the month. Now, it's kind of clunky if we have two different diagrams, right? End part rate begin, change part rate of change begin. Here's the one I like to use. Associated part and associated rate. What I mean by that is that there are two parts and two rates. And the end part always goes with the rate. Right here, 110 is associated with 1.1 or 110%. Change part and rate of change, those are associated with each other. The $10 increase is associated with the 0.1 or the 10%. Now, instead of using this diagram right here, you can build a different type of diagram that shows the relationship. Now, I have 100% here because guess what? That's always associated with the begin amount. Begin is 100%, and then it either goes up or down. Well, in our case, 100% plus 10% equals the rate. Similarly, $100 begin plus the amount of the change, positive $10 equals the end amount. So I want to build a little diagram down here. And I'm going to try and select cell C21 to C27. Right-click on the mini toolbar, and I'm going to use a bunch of colors. From the Fill button, I'm going to choose the very first one up here. And then from the Border dropdown, I'm going to select Outside Border. Now, next to it, I'm going to highlight just two cells. This will be the amount of the change. Right-clicking on the mini toolbar, I'm going to select the next yellowish gold color down, Border, Outside. And then I'm going to select the remaining cells, right-click, and still the third one down, Color Fill, and then the drop-down for Outside Border. Now, watch this. I'm going to cheat. I'm going to use cell references. You can type this if you want. This is the end part. This is the change part. And this is the begin part. Now, below end part, I'm going to say equals the end part is 110. Tab. The change part is this $10. Enter, enter. And the begin amount will be the 110. Now, the relationship is this. Always the formula for end. Whatever the begin is plus the change. All right? Now, that part seems self-evident. But now, right next to it, we're going to draw a similar diagram. Now, I did similar to here, the same structure, but with different colors. And look at this. The end part, well, the parallel to that as a percentage is equal the rate. enter, equals, and I'm going to use the 110%, enter. Now, parallel to the change part is right here, equals the rate of change, enter. The actual rate of change, and I'm going to use the 10%, enter. That means right here, equals, this is the begin, and begin is always 100%. Equals 100%. Now remember 100% when I hit enter, what's the number underlying that? 1. And that will be one of the fundamental formulas that we use when we're doing increase, decrease, and throughout our finance section of this class and lots of other times. 1 plus the rate of change equals the rate. Now down here equals, well, that's the formatted version of the number 1 plus our rate of change. Actually, 100% plus 10%, well, that's 110%. But as you'll see later, we're allowed in our formula to simply take 1 because base is a number that never changes. It's always 100% or 1. But when I Control-Enter, I get exactly the rate. Now, you could format this if you want. But now we have our increase diagram that can help us solve for any particular part and will help us as we down below look through and learn about all of the different formulas associated with increase, decrease problems. Now, all the formulas are exactly the same regardless of whether you have an increase or decrease problem. The actual diagram that we'll create over on the decrease sheet, that will be slightly different. But these formulas are universal. They'll work all the time for increase or decrease. Now look at this. We have 3 different formulas to calculate the begin. If for some reason you were given the end amount and the change amount, well, you could simply take end minus change to get begin. And so that's our first formula, equals whatever the end is minus whatever the change is. Well, of course, that would have to give you the begin. Enter. Begin equals end part divided by rate. Remember our diagram, whatever the associated part divided by the associated rate. When we use our hand, that will give us begin. So equals the associated part, end part, divided by the associated rate. And notice this diagram here, that's the same size, it's a part. This is the same size, it's a rate. So that's what you use in division to get begin and enter. Similarly, sometimes you know the change part and the rate of change, and you need to get back to the begin. Well, we can do the same basic formula, associated part divided by associated rate. More specifically, equals the change part divided by the associated rate, our rate of change. And when I hit enter, that will give you 100. A lot of the trickier problems in increase, decrease problem situations are when you have the end and the rate, or a lot of times you have rate of change and maybe end. Well, remember, rate of change, all you have to do is add 1 to get to rate. Now let's look at our next 3 examples. These formulas are for the end part. Well, the formula we've been using over the last many videos, either base or begin times rate, that is the definition of how we use the rate. There's the begin times our rate. When I hit enter, that will give me 110. That's the end amount. Now remember, since 100 is really 1, we're totally allowed to put a 1 right into the formula. We do not violate Excel's golden rule when we equals the base times, in parentheses, 1 plus the rate of change, close parentheses. We do not violate Excel's golden rule because base is always 100%, which is the number 1. This formula is very common in finance. We'll see it a lot when we get to finance. And enter. There's 110. And of course, if we are given the begin amount and the change part, hey, whatever we started with plus our change and enter. Oh, look at that. It gives me a false. Remember when we studied our different types of formula, the only formula that comes out true or false is a logical formula, F2. So that means I hit the equal sign instead of the plus sign. So I'm going to put a plus. Now we have two formulas for rate. We already talked about end part divided by begin. So let's do that. Equals, there's the end part divided by the begin. Numerator, denominator, when I hit enter, that means 110 parts for every one of the begin or base. Now rate, we talked about that. Because 100% never changes, we can simply say equals 1. Hard code it right into the formula plus our rate of change, and that will always give us our rate. The change part, if we're given the end and begin, we simply say equals the end amount minus the begin, and that will give us the change part. Not only that, but that formula end minus begin will always give us negative for a decrease and positive for an increase. And of course, begin times rate of change, that will give us our change. So there's the begin times the rate of change, and enter. Now, rate of change, we saw how to do it in 2 steps. But oftentimes in accounting and many business classes and many formulas that you see in people's spreadsheets, they will construct the formula like this. They'll calculate the amount of the change, end minus begin, in parentheses, and then compare it to the begin. And that's perfectly all right. Equals open parentheses, always the end minus the begin to get the amount of the change, close parentheses. And we're comparing that change part to the begin. And that will give us the rate of change. Now I have a little pop-up here. Remember, we talked about this when we studied fractions, and we were reducing fractions and adding and subtracting fractions. End minus begin divided by begin. Well, because that's minus, we can break it apart, and we get end divided by begin minus begin divided by begin. Well, any number divided by itself is 1. So that's why this formula works also. End divided by begin minus 1. Lots of times you'll see this in statistics class. I like to use this one because it's fewer keystrokes when entering it in an Excel formula. So equals the end divided by the begin minus 1. And of course, that will give us 10%. And then also, sometimes we're given rate. Well, if 1 plus rate of change gives us the rate, then rate minus 1 will give us the rate of change. So you ready? Equals, there's the rate minus 1. Control Enter, and that will give us 10%. All of these formulas come in handy because sometimes you are given limited data. So if you are only given the rate and you need to calculate the rate of change, that's the fastest way to do it. All right, this sheet we saw, our first increase problem, we saw how to use a table method to solve for particular parts. We saw this visual diagram method. We also saw this circle diagram and a list of all formulas. Now I want to go over to the sheet decrease. Now over here on the decrease sheet, we're going to use our same example. Savings account, beginning of the month, $100. But at the end of the month, we went down to $90. That's a decrease problem. Now, the terms for a decrease problem are exactly the same. The formulas we're going to use, exactly the same. The only thing that will be a little bit different is if we draw our picture down here, our diagram, that will be different. All right, so begin is 100. The end is 90. We can certainly calculate the rate. That is end divided by begin. So there it is. End is smaller than divide by symbol begin. So of course, tab, the rate we get will be less than 1. Now we can format that as a percentage. I already went ahead and added percentage number formatting. Now our change part. Still going to be exactly the same formula. Equals, we always take wherever we ended up, and we subtract where we started. That's a universal formula for telling you what the change is. And what's beautiful about this universal formula is that the sign will tell us whether it's an increase or decrease. Not only that, but when we create our rate of change formula, change part divided by begin equals, well, there's the downward 10 bucks divided by where we start at 100. This will give us a negative also, either 0.1 as a negative or minus 10 pennies, or we can format it. Watch this. Hey, I can just copy that whole cell. Remember F2, that was a relative cell reference with the right formatting. Control-C, Control-V. Escape to turn off the dancing ants. And just as before, the rate is what you multiply by begin to get the end part, and the rate of change is what you multiply by begin to get the change part. We'll test it. End part, begin times rate. There's the begin times our rate. What it means, we're going to get 90 pennies for every 100 pennies from the start amount, and enter. So we get 90 bucks. Equals, I can take the begin times the rock or rate of change, and that will give us how much we either went down or up. In our case, it's down by 10 bucks. Now, I want to draw a picture here, but let's be smart about this. Let's go over to the sheet increase where we created this nice little drawing. Now, all we're going to copy is the formatting, because the position of the different parts will be different, and the formulas down at the bottom will be different. But watch this. Right-click. There's that awesome format painter. When I click that, it copies just the formatting. Now I come over to my decrease sheet, and very carefully in cell B21, I'm going to click. All right. I'm going to click in the top cell, and I want to go back and look at increase. Notice the bigger part was end when we have an increase problem, and the begin was smaller, and then there was the change. When we get over to decrease, we can't have the end filling up the big part because it's not the big part. It's begin. So for a decrease problem, we're going to start with equals begin, enter, equals, and that's 100 bucks. Our end amount is smaller, equals end part and enter, equals the 90 and enter. That makes this the change part, or the amount of change, change part, enter, equals, and there's the minus 10. Actually, I'm doing this in two separate steps. In the past, when I teach this class, some people do it all in a table format. Some people do it in table and diagram. Some people do it just in a diagram. They list their variables, and then they build their diagram, and they do all their calculations there, which is fine also. I've already done my calculations up here, so I'm going to build my diagram using these numbers up here. Well, of course, begin, remember, whatever the part is, they have to be exactly parallel or associated. So equals begin equals 100%. I don't have 100% up there, but watch that. I'm going to click on that. Control-Enter, and then come up here and type 100. Oh, you can tell that it's pre-formatted. We talked about this when we first encountered percentages. If the cell is pre-formatted, when you type a number, that percentage symbol pops up. All right, so begin, the two parts, even though we don't think of begin as a part, the begin amount is always 100%. The end is right here, so that means the associated rate would have to be the rate. So I'm going to click on that rate, enter, and then right here, I'm going to use the 90%. And in this small part, since this is the change part, this will have to be the rate of change. There's rate of change equals, and I'm going to select the minus 10% and enter. Now down at the bottom, our formulas will be different. The actual formula is still the same. It's just where we click, because begin is where n used to be. So where we click is different. The formula is still, please take the begin and add the change. That will give us the ending part. Down here, it still equals 1 plus the rate of change. That formula will always give you the rate. Now we're going to scroll down here and do the same thing just to prove to ourselves all of these formulas. These are exactly the same ones we just did for increase they'll all work on a decrease problem. All right, there's three different formulas for begin. So if we're given the end part and the change part, we can calculate the begin by taking, hey, end minus the change part. Now notice minus a negative, that will be like adding 10. Double negative, that really is a positive, so enter. That gets us back to the begin. Of course, begin, if we have the end part and the associated rate, equals, there's the end part divided by, I'm looking at that size, I'm looking at this size over there, that's the associated rate, and enter. That gets us back to begin. Similarly, change part and the associated rate, that'll get us back to begin also. So equals, there's the minus 10, the change part, divided by our rate of change minus 10. And when I hit enter, that gets us back to the begin. Now there's three formulas for end. We can certainly do begin times rate. There's the begin times our rate of 90 pennies per 100 pennies. And that gets us from 100 to 90. The end part. Well, if we have begin and rate of change, since 1 is a number that will never change, we can simply add that into our formula and hard code it in. Begin times, in parentheses, 1 plus our rate of change, close parentheses. We'll see this formula many times throughout the rest of the class. Whenever you have the rate of change, just add it to 1 and multiply it by the begin, and you get your end. And enter. Of course, if we actually have the change part, then we simply have to take our begin and add the change. Since it's negative, it's just like subtracting. I hit enter, and I get 90 bucks. We have two formulas for rate. N divided by begin, that will give us the actual rate. The begin, that will give us the rate of 90. If we only have the rate of change, we know to get to the rate, we simply add 1 equals hard-coded in 1 plus, and there's our rate of change. That formula will work regardless if it is a decrease or increase problem, and enter. Two formulas for the change. Well, of course, if we have the end and the begin, we just do the subtraction. This is where we ended up minus this is where we started. And since it's a decrease, it's polite. It says, hey, I'm a minus. That is a decrease of 10 bucks. We also, of course, have our rate of change. So equals the begin times the rate of change, and that will get us our change. We have three different formulas for rate of change. Sometimes if we're given end and begin, we want to actually calculate the amount of change right in our formula. Equals in parentheses, because we need to force subtraction first. End minus begin, close parentheses, divided by where we started. Now I want to count 1, 2, 3, 4, 5, 6, 7. So there's 7 clicks we had to do to create that formula. We get the correct answer. If you want 2 fewer clicks, we use this formula. Equals n divided by begin minus 1. I'm counting on my fingers. 1, 2, 3, 4, 5. 2 fewer clicks. And enter. And if we want rate of change and we're given rate, we simply subtract 1. Equals, there's our rate. Notice it's 90, so when we subtract 100%, because it's a decrease problem, that will give us our minus 10%. All right, so those were all the formulas, and they work. Every one of these work for either an increase or decrease. We saw our diagram, which helps visualize the relationships between the numbers. And we started off looking at a decrease problem, our terms, and our basic formulas. Now we've seen increase and decrease in detail, every single possible formula. Now let's go try some examples. I'm going to go over to the sheet example 1. Now on the sheet example 1, the way I do this is I set up a couple of columns. I'm going to list the exact same terms every time, give it a description of what they mean for this problem, write out the formula if I need it, solve, and then I can use a little template like this that I created each time and then change the elements for each one of the parts. Now the terms, every time, just list begin, end part, rate, change part, and rate of change, or ROC. Now notice I listed these because I'm going to be given at least 2 of them, if not more, every time, and then I need to solve for whichever other ones. Now I'm going to read the problem. The Nightly News reported that on Monday, 2/5/2018, that actually was yesterday, the Dow Jones Industrial Stock Market fell by 4.605%, with the largest dollar value drop in history of 1,170.21 cents. What was the starting stock market value and the ending stock market value? Well, it definitely asks for the start and the end amount. And what they gave us was fell by that percentage. That's the percentage change. And this is largest dollar value drop. That's the amount of the change. So actually, they gave us the change part and the rate of change. Let's just enter those in right here, 1175.21, and enter. And down here, I'm going to enter it as a decimal, so I'm sliding 1, 2, so it's 0.04605. And enter. We have to be sure and label it. What does that mean for this problem? Well, it's certainly the rate of change, but specifically, it's something like percent drop in Dow Jones Industrial Stock Market. So that's the percentage drop. And then watch this. I'm going to cheat. I'm going to copy this up. It's text. And then change this unit symbol to dollar amount drop in Dow Jones Stock Market. And we could format these if we want. Actually, watch this. I have my ribbon tabs collapsed. I can right-click and uncheck collapse. I'm going to change this to currency. And this one, oh, you know, there's no built-in 1. So if I choose this, it's going to temporarily hide some decimals, but I'm immediately going to increase. Now, the begin amount, I can label that. Something like dollar value of DJI stock market at begin of day, Control-Enter, and I'm going to copy this one down too, and change the begin to end. I could add some word wrap if I want. Now we have a choice of what formulas to use, and I got to show you a great trick. Let's come over to either decrease or increase, and I want you to highlight this. This is like our universal formulas we can use for every problem. Well, let's copy it, Control-C, and then let's come over. Now, I don't want to put it right in the sheets. I want it as a picture object. So watch this. I'm going to select a cell, come up to Home, Clipboard, drop down for Paste Special, and there's a bunch of icons. In earlier versions, they'd list the names, but now you have to hover. Like that's Paste Values Only. But look at that. That's Paste a Picture. This is really cool. That's Paste a Link Picture. That means if it changes, the picture will update. I'm just going to paste it as a picture since this won't change. Now, one thing annoying about copying cells and then pasting it as a picture is it sees through to the background. So I'm going to select this. And just like we would use Control-1 to format the cells, we can format any object in Excel. Control-1, and this opens up the task pane for formatting a picture. I'm going to click on the Paint Bucket, Fill, Solid, and I'm going to change this to white. All right, now I'm going to close this. And then we can use this, or you can use this copy and use it on every one of the problems or on your test. Now, there's one thing wrong with what we did here, and it's that we agreed that if it's a decrease problem, these both have to be negative. So no problem. I'm going to put this in edit mode and enter minus in front of it, enter. F2 and put a minus in front of here and enter. If we didn't agree to enter increases and decreases as positive or negatives, then all of these formulas would be different. But once we agree to just enter, in essence, the only thing we have to enter is decreases as negatives, then we just use these formulas in every situation. Now, we have our list of formulas, but sometimes even when we have minimal data, it's helpful to fill out this diagram. Now we have the change part and the rate of change. So right here where we're going to put our values, I'm going to say equals and get the change part, equals and get the change amount. Over here, equals, that's the rate of change, and that's the actual rate of change they gave us. Now, we don't have anything else on the value side, but we do always have something on the rate side here. We always have the begin. That's always 100%. As soon as we see that, we know that these are additive. In order to get the rate, we add these two. Now, actually, you can do that, as we mentioned, right here in this diagram. So equals, this is the rate. And right here, I could say equals 100% plus that rate of change. And that correctly gives me the rate. I also think we have an associated part and an associated rate. So right here in our diagram, we could say equals, well, there's the associated part divided by the associated rate. And just like that, we have the begin stock market amount. If you're using your table diagram up here, I'm definitely going to write out the fact that this is 1 plus ROC to get the rate. And right here equals 1 plus what they gave us, the rate of change. As soon as we have the rate, move this off to the side. We also have these two associated parts of the begin, change part divided by rate of change, and tab. Equals, there's the change part divided by our rate of change. This is the same calculation we just made down here. And when we hit enter, there we go. Now to get the end part, that's begin times rate. And we have those two things equals, there's the begin times our rate. And there is the ending amount for the stock market. We can make the same calculation down in our diagram. End is always going to be begin plus our change part. And we get the same number. Now, in essence, what we did is we did our formulas up here and down here. So that is a check. We could also make some other checks, picking from the list. For example, we could check those two, calculating end and ROC. Now, before we go over to example 2, notice this example came from a nightly news report, and they reported 4.605%. But let's go over to example 2. And you suspected that the nightly news report on Monday rounded the percent used to describe the stock market fall. So they used 4.605%. So you want to go and find the actual begin and end amounts. And we can use Yahoo Finance to do that. And then we can calculate our own rate. If we go over to Google and type in Yahoo Finance, here's our link. This is a great place to get financial data. Right at the top, let's click on the Dow 30. And look at that. Today, the Dow went up by 567 points, or dollars, right? Yesterday, it went down by over 1,000. But right over here is historical data. And you can actually type in any stock, name, or ticker up here and get to this exact place where you can look up historical data. I'm going to click on historical data. And February 5th, that was the end of yesterday. I'm looking for the adjusted close. So I'm going to copy that number right there, Control-C, go back over to Excel. And this is the end of yesterday, which is what we want. Up here, I want to get the start. Now, the begin amount for Monday would be the end amount on Friday. So I'm going to get the adjusted close right here. Control-C, come over here, and paste. Oh, look at that one I pasted. I copied some extra space or something from that website. If I hit Enter, there's the default alignment telling you it's text, F2, and then backspace. There we go. Now we have two numbers. We can definitely calculate the rate. End part divided by begin equals, there's our end divided by our begin. Now, I want to get to rate of change. And from our list of formulas, or if you've practiced a lot, you know that rate of change is always going to be the rate minus 1. Since our rate is already less than 1, this will come out negative. Equals, there's the rate minus 1. Control-Enter. And there it is. So you see they did round it a little bit. 0.605. There's the 604,881.63. If we calculated the change part, begin times ROC equals there's the begin times our rate of change. If you want to do this diagram down there, by all means use that diagram. I'm going to check this. Let's calculate the begin. So I'm taking associated part divided by the associated rate equals there's the associated part divided by the associated rate. And when I control enter, I better get exactly equal to the begin. All right, on the answer sheet, you can see everything, both the table method and the diagram method. Now we want to go over to example 3. All right, example 3, the value of Iowa farmland increased 4.3% this year to a statewide average value of $1,857 per acre. How much per acre did the Iowa farmland increase this year round to the dollar? Well, it looks like we have an increase problem. That's the rate of change. I'm going to come down here. And of course, before we start any problem, we just list our 5 terms either in our table or down here in our diagram. So rate of change, I'm going to format as I type 4.30, and when I add a percent symbol, that'll enter it as a percent. The title for rate of change, something like percentage increase in Iowa farmland statewide average for the year. So that's a percentage increase. I actually already had wrap text there. Now we're given the end part. This is where it ended up, 1857, and enter. I'm going to enter something like Iowa farmland statewide average end value. Control enter, and I can copy that up and just change the end, double click, and type begin. Now if I'm doing the diagram, we have the end, enter, and we have the rate of change. Is that it? Now remember, if we use this diagram, what's nice is we know we always are going to have begin. Now this is an increase, so the rate and the end part are the big pieces. But begin, we always have that on the percentage side because it's always 100%. Once we have 100% and the rate of change, we simply add the two to get rate, equals this 100% plus our rate of change. Now visually, what's nice about this is we clearly see there's an associated rate and an associated part. So we can definitely calculate the begin equals associated part divided by the associated rate and enter. So there is the begin amount. Now the change, now that we have end and begin, we simply say equals end minus begin. The advantage of the diagram is it's visual. We're not looking over here at our formulas. Now the goal was to round this to the dollar, but I'm going to do my calculations up here and leave a trail with a written formula. Now rate, instead of 100%, I'm going to say 1 plus rate of change, and then here's our formula, equals 1 plus, and then there's our rate of change. Once we have that, we have an associated part and rate. And part divided by rate equals there's the end part divided by our rate. And there is the begin amount. That means the change that we're supposed to round, always end minus begin. So here, there's the end amount. There's the begin amount. There it is, unrounded. I'm going to come over here, equals round. Now this says to the dollar, comma. We know dollar is 0. That's the position to round to. Close parentheses. So 77 bucks. That's how much it increased on average for the year. I want to check this amount right here. I get to pick whichever formula I want. I'm going to check for rate of change. Better be change of part divided by begin. There's the change part I just calculated divided by the begin part I just calculated. And look at that. It's 4 pennies. If I remove the number formatting, general, There it is. There's the decimal that is represented by 4.3%. All right, that was an increase problem. Now we want to go over to example 4, and we want to talk about markdown and markup. Now, markdown and markup are common examples of decrease and increase in retail, meaning where we make sales. Here's our first example. Original price of the Lego set was $10.50. And you saw a sign that had a markdown. It said 10% off. And our goal is to calculate the reduced price. Well, we know when we get the rate of change, if we add that to 1, that's the rate. And rate times begin gives us the end amount. This formula right here is so common everywhere, not just in business, accounting, finance, but all different situations. We're given the rate of change, and so we use this formula right here. If we're getting to the end, reduced price equals, well, where we started times, in parentheses, 1 plus our rate of change, close parentheses. When I Control-Enter, that's the reduced price. Now we could check this, equals 1 plus. Hey, wait a second, I thought we just calculated that, but there it is, 90%. But now I have a part and an associated rate, and I could do division to try and get back to the begin. There's the associated part. That's the end after the discount divided by the rate, and I better get 10.50. Markdown. Whoops, that's not supposed to be there. We had $600. That was the original price for the generator before the Seattle windstorm. Sometimes when there's a high demand for a particular item, the price goes up. The markup was 20%. No problem. The new price equals wherever we started times this often used in parentheses 1 plus whatever the rate of change is, up or down. In this case, it's a markup. So Control-Enter. Wow, so the price is $720. We could calculate this a slightly different way. Amount of change, or our change part, equals, well, there's the begin times the rate of change, or markup. That'll give us the amount. And so to get back to the begin, we have an associated rate and an associated part equals, there's the associated part divided by the associated rate. And there we go. Markdown, that's just a decrease. Markup, that's really an increase. Now let's go over to example 5. Here's an example we saw a couple videos ago. The nightly news reported that GE Company has sales this year that were 87.5% of last year's sales. If last year's sales were $5 and so on billion, what were this year's sales? What was the rate of change? Now, as we talked about before, when we see 87.5% of last year's sales, that's the percentage of is multiplying last year's sales. That's amount. So if we multiply rate times the begin, we'll get the end. And of course, we have a formula to calculate rate of change if we're given the actual rate. So last year's sales, $5,350,500,000. The rate we're given that 87.5, and we can see the cell is pre-formatted because the percentage symbol comes up. And when I enter that, I can calculate the end part equals begin times the rate and enter. The change part, the amount of the drop, well, it's always the end amount minus the begin amount. And when I hit enter, there's the drop. Oh, it was only 668 million down. That's a lot. Now, rate of change, well, equals, we take the rate and we subtract 1. Because this is smaller than 100%, we will get our negative rate. Now, let's check. And I'm going to check for ROC, and we can calculate that as the change part divided by the begin. Equals, well, we just calculated that change, and we're going to divide it by and compare it to the begin. And when I hit enter, 13 pennies again. Remember, that's number formatting. General, and we can see There's the decimal that's represented by that percentage. Down here, if you like the diagram method, there's the begin. We add the begin to the change to get our end. Over here, we have begin plus rate of change, which is negative. That gives us our rate. Oops, I see I forgot to document the formulas we used. And there they are, 1, 2, 3. Now, that was example 5. We have one last example. Let's scroll over, and I want to go to the sheet stocks. Now, this is our last example for this video, and what I did is I went and found for each one of these companies at Yahoo Finance, there's the ticker symbol. I found the price of each one of these stocks, 3/1/2007. And here's the price as of yesterday, when there was over a 1,000-point drop. And we want to calculate the rate of change, often referred to as percent change or percent of change. Now, I'm going to use the 5-click formula instead of the 7-click formula for percentage change or rate of change. Equals, it's always the end divided by the begin minus 1. Control, Enter. Wow. Amazon in 2007, we could have got it for $38.85, and now it's selling for $1,390, even after that huge drop. That is a huge return. I'm going to double click and send it down. Those are relative cell references, so when I F2, those should all work. The only one that went down over that long time period was Bank of America. Look at that. Microsoft up by over 200. McDonald's. Wow. Now, here's the same companies, but if you bought these just a few days ago on January 31st and then sold them during Monday's big sell-off, let's find out what your return would have been, meaning you only held the stock for a couple days. Equals the end divided by the begin minus 1. That's our formula. Control Enter, double click and send it down. Oh, yeah, of course. If you bought it just a few days ago and then had the big sell-off, then you have huge percentage losses and all. What does that mean right there? That means for every $1, you lost 4.2 pennies. Up here, what does that mean? For every $1, you earned 3,478 about pennies. Or about, for every $1, $34.78. Now we can check this. There's the rate of change. If I create a formula, associated part divided by associated rate, well, I have the end, but I have the rate of change, but no problem. I could take the end divided by associated rate. Well, I created the associated rate, the actual rate from our rate of change. So here, equals, there's the associated part, the end divided by the associated rate. Well, I have to go 1 plus the rate of change to get to rate. Control Enter. And copy it down. And sure enough, all the way down, F2, that is working. And that's a relative cell reference. Control C, Control V. That better give me the correct begin amount also. And I love Excel. It's so easy and quick to make lots of calculations. F2. All right, now there's a bunch of great homework problems. There's 7 homework problems for you to do and practice. And in this video, we saw a lot of examples of all of the different formulas we can use when we have increase or decrease problems. Here we saw a stock example where we created the rate of change and saw it over a very long period and over a few days. Back on example 5, we were given the rate and the begin sales, and we calculated the end value and the rate of change. Back on example number 4, we talked about markdown and markup, really just decrease and increase problems. Back on example 3, we talked about Iowa farmland. We had a great example here. Example 2, we talked about the Dow Jones Industrial Stock Market drop yesterday, Monday, February 5th. And we went out to Yahoo Finance and found some numbers and made some calculations. Over here, we did another example on the Dow Jones Industrial Stock Market correction. And back on the sheets, decrease, very importantly, we saw the essence and learned how to do a table and diagram method and saw all the different formulas that work for either decrease or back over here, the increase problems. All right, that was a lot of fun with increase and decrease. If you like that video, be sure to click that thumbs up, leave a comment, and sub, because there's always lots more videos to come from Excel is Fun, including next video. Video number 24 will be about banking and bank reconciliation. All right, we'll see you next video.